Hello everyone. So today I am going to explain about and about to start new chapter, that is equilibrium. So equilibrium is a common process we can see like in our surroundings also, day to day life also. So we will discuss some examples also, and we will go for new examples also, which will give you more confidence about the equilibrium. So first of all, we will start with the equilibrium in physical processes. So first of all, what are physical processes? Physical processes are evaporation, boiling, freezing, melting. You know, evaporation is a very slow process. It takes in water bodies. Like water bodies, if you take, so evaporation takes place slowly. At very low temperature also evaporation can take place. Boiling takes place at very high temperature, like every substance or liquid has some boiling point. Freezing means when some gets freeze, molecules get very close to each other, then freezing happens. And melting is when solid convert into liquid phase, that is melting. So these all are physical processes which we see in a day to day life also. Like whenever we are boiling some hot water, then boiling is taking place. Melting of ice is a melting process. And one more physical process is there, that is sublimation. Sublimation is one of the physical process in which solid is directly converted into vapor phase. So in evaporation and boiling, both are actually this kind of same concept, but the difference is between evaporation and boiling is what? Evaporation is a slow process and boiling is a fast process. Evaporation takes place slowly, like in our water bodies there is evaporation of water, then formation of clouds. So it is a very slow process. And boiling is a fast process, because here for boiling you use burning flame, or you raise the temperature. So boiling takes place like this. And freezing and melting takes place when you are completely lowering the temperature, and melting takes place when solid is converted into liquid phase. So these are some physical processes which we see in a day to day life. Okay, and sublimation is direct when solid is directly converted into vapor phase without converting it into liquid phase, and that is the sublimation process. And sublimation process we have seen in day to day life in like camphor, in iodine, then sublimation naphthalene balls are there, in which sublimation takes place. Directly solid is converted into vapor phase. Like when you keep naphthalene balls in warm clothes, then if next season you will see, if you open your warm clothes, your naphthalene balls become very small, or sometimes it completely vanished. So it is because sublimation process, and your naphthalene balls completely convert into vapor phase. Okay. So next we will talk about actually what is equilibrium and what it signifies. First of all, the sign we use for equilibrium is this. Okay. So you know the arrow, this arrow signifies that reaction is going in the forward direction, and this arrow signifies that the reaction is going in the backward direction. Okay. So this is the forward direction arrow, this is the backward direction arrow, right? So when these two arrows, if you merge and you just keep it as a half arrow for forward and half arrow for the backward, then this is the sign, this is the symbol we use for equilibrium. Equilibrium means the reaction half is going in the forward reaction, half is going in the backward direction, or you can say equally it is going in the both direction. Okay, so equally it is going in the forward and equally it is going in the backward direction. So this is the sign for equilibrium. Next, very important thing about equilibrium is equilibrium can only be attained in a closed system. In a closed system means all walls are there, like there are 4 walls and it is completely a closed system, and there is no direct contact with the nature or atmosphere. So it is a closed system. So if you are talking about solid liquid equilibrium, you have seen this also in your day to day life, like solid to liquid. For example, if you are melting ice, okay, you are taking ice and you are giving temperature and it is converted into liquid phase. So this is a process in which solid and is converted into liquid phase by a physical process called melting. But equilibrium is attained at some point. If you are fixing some temperature, you are fixing some pressure, then what will happen? The amount of ice converted to water will be equal to amount of water will converted to ice. Means ice and water, there will be equilibrium. Like after some time, if equilibrium is attained, you will see that the ice, the amount of ice, the mass of ice is also same and the mass of water is also same, but still the process is going on. It is not stopped. It is always dynamic process. Means you by observation you will notice that it is stopped, but it is not stopped. It is going on. Always equilibrium process is always in dynamic and always moving either forward direction or backward direction. So next we are taking example of liquid and vapor. So liquid is converted into vapor phase and vapor to liquid. So this is also takes place in a closed system. Closed system, if you take isolated system, then your water, if you are boiling some water and it is converted into vapor phase, then again here condense and get back to the container. So this is the process where liquid is converted into vapor and vapor again after condensation converting into liquid. So here liquid is converted into vapor and vapor to liquid. After some time you will notice the amount of vapor converted to liquid and liquid converted to vapor become equal. You will notice that there is no change, but there will be change which we cannot see. It will be going on. Like previous I have told you, it is always dynamic process. It is moving in forward and backward direction. So it is always be there. Next is solid vapor equilibrium. Solid vapor equilibrium also takes place in a closed vessel. Here I can take the example of iodine. Iodine solid. Iodine is a solid, but it converts directly into iodine vapor. Okay, without. So this process I have told you, this is sublimation. So in sublimation process, what happened? The solid convert into vapor phase without converting into liquid phase. So in this case also you can see that iodine is converting into iodine vapor, and iodine vapor again condensed back to iodine solid. So there will also be equilibrium and it is dynamic. The process will go hand on hand, forward and backward both. So this is how I can explain all the physical processes and their equilibrium process. So main key point for equilibrium is their main two key points are: first, it takes place in closed vessel, and second, it is a dynamic process. Okay. So that's it for today. Thank you very much. Good morning. So my next topic is in equilibrium in chemical reactions. So in chemical reactions also we will study the concept of equilibrium. In a chemical reaction, if you see A plus B is a reactant. This is a reactant, and it will give C plus D. It is a product. So when there is an equilibrium between reactant and product, then that equilibrium is known as chemical equilibrium. Okay. So in this graph you can see what is happening. Here I have taken concentration in the x-axis and time in the y-axis. Okay. So if I am taking time in the y-axis and concentration in the x-axis, you can see that with time the concentration of the reactant, that is A and B, concentration of the reactant A and B is decreasing, and with time the concentration of the product C or D is increasing. So when a reaction is taking place, for example A plus B is converting to C plus D, then what will happen in the forward direction? In forward direction, what will happen? The concentration of A and B will decrease and C and D will increase. So here you can see at one point, after some time, you can see that there is a straight, about to get straight line, the curve is getting straight, so that means that equilibrium is achieving. So at one point you can see there is an equilibrium state has been achieved where both lines became parallel to each other. So this is the equilibrium state. So equilibrium state is very important in studying the chemical reactions. Either reaction is going in the forward direction or in the backward direction. For example, if I am taking any reaction in the backward direction, like this is the backward reaction, so what will happen? The concentration of C and D will decrease and concentration of A and B will increase. So forward direction and backward direction will, when I'll mix, like when half the reaction is going in the forward direction and half in the backward direction, then what will happen? Then it will happen that A plus B giving C plus D means the amount of formation of A plus B is equal to amount of the formation of C plus D, and amount of dissociation of A plus D and disappearance of A and B is also equal to the disappearance of C and D. Means both are going in an equal way. Like both are, if dissociating, then both are associating also. If reaction is going on in the forward direction, then it is going in the backward direction also. Let's study it with some color example. With this you can understand more. So let's take the color of A plus B mixture. Suppose this is my reactant A plus B and it is giving me pink color. It is giving me pink color. Okay. And when in the beaker you have taken A plus B, you can see in the beaker that your beaker will be in pink color. But when after some time when reaction will take place and it will go in the forward direction, I am talking only about forward direction. If it is going only in the forward direction, then what will happen? The color of the beaker will change from pink to orange. Pink to orange. Okay. So after completion of reaction, the beaker color will become completely orange. But when equilibrium is attained, when means reaction is not going completely forward, it is going half forward also and half backward also, then when equilibrium is attained, the color will neither be pink nor be orange, it will be in between. For example, it will be light yellow. It will be light yellow. So with the help of this color only you can identify that this is light yellow in color, that means equilibrium has attained, because initially it was pink color, after reacting it was orange color, and if yellow color has come, pale yellow color has come, that means your equilibrium has attained. So with this color example I have explained you like how chemical equilibrium you can notice in colored reactions. Okay. For example, next we are taking a very important example in Haber's process, that is formation of nitrogen and formation of ammonia from nitrogen and hydrogen. If you are taking nitrogen and hydrogen and formation of ammonia will take place. So you know nitrogen is a gas, hydrogen is a gas, ammonia is a gas. So in this process also equilibrium is attained, and equilibrium is attained can be noticed by using mass spectrometry. Like when you in mass spectrometry you will observe the masses, you will notice the masses, and if you observe the masses you will see that the amount of ammonia and amount of nitrogen hydrogen is almost same. The amount of ammonia and nitrogen and hydrogen is almost same, and equilibrium has attained, because if there will be no equilibrium then amount of ammonia will be larger, because products will be in larger quantity as compared to reactant, but amount of forward is equal to amount of backward, that means masses on the both side will be the same. Okay, so in this example you can also notice the very important concept of chemical equilibrium. Okay, so for today this much is fine. I hope you're doing fine. Thank you so much.